I want to give an example of solving a problem using logarithms. So here I have a simple equation where I'm saying 3 times 2 to the x minus 1 equals 0. Now, my eye is immediately drawn to this 2 to the x. This looks like the most complicated thing in this equation. And I have a vague idea that anytime I see an exponent and I'm trying to solve for x, I should be using a logarithm function. Now, that's actually going to be our last step in this problem. Anytime I am performing algebra, I like to think of it as unwrapping a present. So the thing that I want, that x, is all the way inside. But I need to use my tools, my addition, my subtraction, my multiplication, and my division, to unwrap from the outside and work my way in to get what I want. So I have some stuff multiplied together, and then subtract 1, and that equals 0. If I was going to divide that 3 out, I'd have to divide it from every single term I have on the left side and divide it from every single term I have on the right side. But I can actually make it so that each of these sides of the equation only has one thing in it if I get rid of this minus 1 first. So as I unwrap my present, I'm going to add 1 to both sides. On the left, now I have 3 times 2 to the x. On the right, I have positive 1. All right. So now I want to get to this x. It's stuck up top here inside of that exponent. But I also have this 3 multiplied out on the front. Since I already moved the 1 over to the other side of the equation, now it is easier for me to divide both sides of the equation by 3. On the left, I'll have 2 to the power x, and on the right, I'll have 1/3. This is looking a lot simpler now because here is that exponent that I'm having trouble with, and now it's just equal to a fraction. Let me copy that over. 2 to the power x equals 1/3. Since I have this exponent, and I'm trying to solve for the value of x, I need to undo the exponentiation operation. The same way that subtraction undoes addition, and the same way that division undoes multiplication, logarithms are the operation that undo exponents. Now, it is a little tricky because we always have to match the logarithm to the base here. So this is a base 2 exponential. So to solve this problem, I need to use logarithm base 2. So I've put a little 2 underneath to remind me what I'm using. And I actually have to use the log function on both sides, just the same as I have to subtract on both sides or I have to multiply on both sides. So I can say that the logarithm of 2 to the power x is equal to the logarithm of 1/3. That's my logarithm step. On the right here, this is just a number, right? I have a function, logarithm. I have given that function an input, 1/3, and log base 2 of 1/3 is just some real number. Right now, I'm not terribly concerned with the decimal expansion of this number. I'm more concerned about the algebraic manipulations. Because I picked a logarithm that matches my base, and I can tell because what I have underneath matches exactly my 2 to the x here, this whole expression simplifies down to just x. That's happening again because I've matched my logarithm to the base I'm using. So on the left-hand side, I have fully unwrapped my present. I've got an x. And what is that x equal to? It is equal to the logarithm base 2 of 1/3. And that's the solution to this problem.